Hi everyone, it's Mr. Hamilton here, and welcome to this video on solving problems using quadratic equations. Specifically, we're going to do a lot of word problems today and understand how to model an equation and how to solve it according to that word problem. So anytime we encounter a word problem, the first thing we want to do is read it over at least twice. I'd actually suggest you read it once, then a second time, draw the diagram the second time, and then read it a third time as you check your diagram to make sure it's correct. Once your diagram's done, you define your variables and write your equation. It's important you define variables and don't just write an equation, otherwise the person reading it doesn't know what the variables represent. We want to solve it, then we want to reread the question and state the solution, and then if we have time we can check the left side and the right side of that equation and ensure it makes sense and is correct. Once you have an equation that's equal to 0, and we're going to get this at this step right here, once we have that, write the equation, we'll rearrange it so it equals 0. Then we try to common factor if we can, and if we can fully factor, we go ahead and do that. If we cannot fully factor, only then do we use the quadratic formula. So let's go ahead and look at the first example together here. It says define variables, write the equation, and solve the following. The product of two consecutive odd numbers, don't miss that, odd numbers, is 1023. What are those two numbers? Well, for example, we know the odd numbers are like 1, 3, 5, 7, etc. And so if we have one number that is x, the next consecutive just means the next one. The next odd number is going to be 2 bigger than that. And so we go x plus 2 is the second number. So if we take the product of these two, this is just multiplied, so this times this, that's the product, we multiply those two together, is equal to 1023. What we need to do now is we need to set it equal to 0. So in this case, we're going to go x times x is x squared, x times 2 is 2x, and then I'm going to subtract 1023 from both sides of the equation. And so I'm going to get it equal to 0. I could do that up in the line above if I wanted to. Subtract 1023. That's going to cancel it off the right. So that seems like something that might be factorable, but the way we know it is factorable is it's asking for two odd numbers. And so those are going to be whole numbers. And so right there we should be able to find two numbers because those are going to be whole numbers, and factoring always gives us whole numbers. So two numbers that add to 2 multiplied to negative 1023. Now you might think, okay, there's a lot of factors of 1023. Here's a trick. If it adds to a very small number, what we can do is we can go ahead and take the square root of what it multiplies to. Now obviously it's negative 1023, so you can't take the square root of a negative, but you take the square root of the 1023. And in this case, if we take the square root of 1023, we get a number of 31.98. Well, so you say, well, how am I supposed to factor with a number that's 31.98? You're not supposed to factor with that. The hint is that two numbers are going to be close to that and add to 2. And so if you think about it, okay, if we have 31 and 33, if they add to positive 2, that means that smaller one has to be negative. Those actually multiply to negative 1023. And so those are our factors in this case. So go ahead and we factor this. We get x minus 31, x plus 33 is equal to 0. And just over on the right side, I'm going to continue to solve this. That means that x minus 31 is equal to 0, or x plus 33 is equal to 0. Well, this means x is positive 31, and this means x is negative 33. Well, that means that x plus 2, the next consecutive number in the first case is 33, because if we add 2 to 31, we get 33. And if we add 2 to negative 33, we get negative 31. Well, there are actually two solutions for these two consecutive odd numbers. And so those numbers are 31 and 33, or negative 33 and negative 31. And so we should conclude incorporating both of those solutions. Therefore, the two consecutive odd numbers are 31 and 33, or negative 33 and negative 31. All right, let's move on to the next two examples. What I'll do is at the end of the video, I'm going to show you the solutions for these last two examples, but I'm not going to work these out. I'm just going to set up the equations with you now. Number 2 says the sum of the squares of two consecutive integers is 181. What are the integers? Okay, sum is plus, squares is squares of two consecutive integers. It doesn't say two consecutive odd integers or even integers. So they're 1, and then the next one is just 1 more than that, is 181. So the sum of the squares. So let's let x be the first integer. Again, they're whole numbers, so this is better be something that's factorable. And that means the next consecutive one is the second integer. So if we write an equation for this, we would go ahead and write x and x plus 1. So the sum of the squares. Okay, so the sum, so we're adding those together, of the squares. We need to square the first number, and we need to square the next number. Is 1,000, not 1,023, I'm going back to the last question there, is 181 here. So you can go ahead and rearrange that, set it equal to 0, and solve that. Keep in mind x plus 1 squared is a perfect square, so it's not x squared plus 1. That doesn't work. It's not what it works out to. It works out to be a trinomial. At the end of the video, I'll, again, like I said, show you the solution for that. The next question says, a triangle has a hypotenuse of length 70 centimeters. As soon as you see that word hypotenuse, that ought to give you a hint of something. That means it's a right triangle. If the height is 2 centimeters longer than the base, what are the base and height of the triangle? Draw a diagram to find variables and write the initial equation. Then determine a strategy to solve. So what we're going to do here is I'm going to draw my right triangle. And I know the hypotenuse is 70 centimeters. And I know the height is 2 centimeters longer than the base. So if the base is b, then the height is equal to b plus 2. And so let's just define that. So we're going to let let b be the base length. Now notice there's no information given here about the area, so we're not going to solve anything with the area. What we are going to solve is the Pythagorean theorem, because we know it's a right triangle. And so using the Pythagorean theorem, it says a squared plus b squared equals c squared. And in this case, the a squared side is the height, so it's b plus 2 all squared plus b squared is equal to 70 all squared. And so it's a matter of now expanding that out, setting it equal to 0, and then solving that. Now, in this case, we may not find that it's factorable, but we always try to factor first, especially common factoring. If you don't find that it's factorable, then you can come back and use the quadratic formula. So go ahead and use that strategy, and again, at the end of the video, I'll have the solution for this posted. This final example is for an object flying through the air, and it's one of the most common types of examples we're going to see. It says the height versus time of a rocket flying through the air can be modeled by the formula h equals -1/2 g times t squared plus v naught. You say this as v naught plus d naught, where h is the height above the ground in meters and t is the time after launch in seconds. G, this g in the equation right here, is the acceleration due to gravity. It is always going to be 9.8 meters per second squared on Earth's surface. V naught is the initial vertical velocity, so it's how fast it's going straight up. It might have a part of it that's going to the side, but the part that's going straight up is what we consider for the V naught part of that. It's in meters per second. And then D naught is the initial height in meters above the ground. And so this will work for any object that's just flying through the air, any projectile flying through the air. We can sub these numbers in. G is always going to be 9.8, and then V naught and D naught depending on how fast it's going upwards initially and what its initial vertical height was. Here we have this information. The rocket starts at a height of 3 meters above the ground with a launch velocity of 58.8 meters per second. And so in this particular case, it starts off by asking us, what is the equation for the motion of the rocket? And so we can go ahead and take that equation that we had, h equals -1/2 gt squared plus v naught t plus d naught, and we're going to substitute in these values. So in this case, h equals -1/2 times 9.8 times t squared plus v naught, that is given to be a launch velocity of 58.8 meters per second. We don't need to put the units in there. We can just put 58.8 times time, plus d naught, it's launched from 3 meters above the ground. So that's our equation. We can simplify that one more step. We're going to say that -1/2 times 9.8, this a value is always going to be the same for a projectile in terms of time. So this is going to be what it simplifies to. So that's in standard form. It's important just to note that. So the only thing that equation tells us in terms of a graph of height versus time is that the initial height is 3 meters. So what is the height of the platform? It's 3 meters. That's the y-intercept. The y-intercept is the initial height of the platform. Now it asks, what's the height of the rocket after 2 seconds? Well, we go ahead and we want to know 2 seconds. And so we're going to substitute time equals 2. And so that gives me h equals negative 4.9. I'm going to use my equation that I simplified. I'm going to substitute 2 in for t. Everywhere I see the t, I'm going to put a 2. And then I'm going to arrive at the following numbers. I get negative 19.6 plus 117.6 plus 3. And then when I add all those together, I get a value of 101. And we can conclude, therefore, after 3 seconds, this rocket is going to be 101 meters. After 2 seconds, after 2 seconds, the rocket will be 101 meters above the ground. It's a pretty good rocket if I don't say so myself. The question goes on and asks this. It says, what is the maximum height reached by the rocket? How long does the rocket take to reach this height? Now, you could, if you were in the applied class, you could just graph this on Desmos to answer the question like this. But in the academic class, you have the option to be able to complete the square. And that's what I would argue the easiest way to do this, particularly if we have decimal values in the equation, because it's probably not going to be factorable. So finding the zeros and then finding the midpoint of the zeros, it's probably going to take a little bit of time. So let's go ahead and let's complete the square to find this maximum. So h equals, I'm going to common factor out negative 4.9 out of the first 2 terms. I'm going to be left with t squared minus 12t, because negative 4.9 times negative 12 gives me 58.8. And then I'm going to have the plus 3 outside of that. Now that magic number is going to be 12 divided by 2 squared. So it's the coefficient on the t term all squared. Well, 12 divided by 2 is 6. 6 squared is going to be 36. And I go ahead and I add that and subtract it inside the brackets. So t squared minus 12t plus 36 minus 36 plus 3. So now what I need to do is I need to go ahead and multiply the negative 4.9 times the 36. And I get the following. That gives me a number of 176.4. And then when I add it to 3, that simplifies for me. T squared minus 12t plus 36. The square root of t squared is t. The square root of 36 is 6. The sign between them is negative. So it's t minus 6 all squared plus 79.4. And so we conclude, therefore, the max height is 179.4 meters reached after 6 seconds. Well, there you go. We've been able to determine what the max height and the max time for that is as well. So the next part of the question says, over what time interval is the height of the rocket greater than 150 meters? And so if you're in the applied class, you could just use Desmos to solve this. But if you're in the academic class, I would expect that you could actually solve this. And the key here is to sub in h equals 150 and then rearrange that and solve for the time. I'm going to pick that up in the next YouTube video from here.